Every picture of the solar system follows the same rhythm. Mercury, Venus, Earth, Mars. Then, instead of another planet, there is only a wide band of drifting rock. At first, it doesn't seem strange at all. The asteroid belt has been printed in textbooks for generations. It's simply part of the solar system. Most of us stop thinking about it before we even learn its name. But imagine seeing it for the first time. Millions of rocky bodies all circling the sun in the same region. Not gathered into a planet. Not scattered across the solar system. Just left there. The obvious explanation almost writes itself. A planet must have been here once. Something destroyed it. The fragments never found their way home. For more than 200 years, that was exactly what many people believed. It looked right. It felt right. There was only one problem. Nobody had ever asked whether there was enough rock. Eventually, astronomers did something almost disappointingly ordinary. They added it up. Every asteroid, every large body, every known fragment between Mars and Jupiter. The answer arrived as a number, but it behaved more like a verdict. Gather every asteroid into one place. Melt them together. You don't get a planet. You don't even get a moon as large as ours. The picture changes instantly. Those rocks cannot be the remains of a destroyed world. There simply aren't enough of them, which means something even stranger has been sitting in front of us all along. The empty space is real. The missing planet is real. Only the explosion never happened. And somehow, that turns out to be the easier part of the story. Because once the idea of a shattered planet disappears, another picture begins to emerge. The asteroid belt is no longer the graveyard of a dead world. It is the construction site of one that was never allowed to exist. For a long time, astronomers assumed the answer had to be simple. If a planet had never formed, perhaps there just wasn't enough raw material. After all, you can't build a house without bricks. You can't build a planet without rock. It sounded perfectly reasonable. Until scientists tried rebuilding the early solar system. Not by looking at today's planets, but by working backwards. Strip away billions of years. Put the planets back where they began. Spread the original building material across the young solar system. Something immediately refused to fit. Between Mars and Jupiter, the models kept demanding far more material than exists there today. Not a little more. Enough to build another world. Roughly 1 to 2 Earth masses of rock should once have occupied that region. Today, almost all of it is gone. Not hidden. Gone. That changes the story again. The asteroid belt wasn't born small. It became small. Somewhere in the solar system's earliest history, more than 99% of the material that should have built a planet disappeared. Not because the rocks stopped growing, because the rocks themselves kept disappearing. At first, that almost sounds impossible. Space is unimaginably vast. If millions of objects are orbiting in roughly the same place, why wouldn't gravity slowly pull them together? That is exactly how every other rocky planet began. Tiny grains became pebbles. Pebbles became boulders. Boulders became mountain-sized bodies. Gravity took over, and the process accelerated. The larger an object became, the more material it attracted. Planet formation is usually a chain reaction. Growth makes even more growth possible. There is no obvious reason why the same process should suddenly fail between Mars and Jupiter. In fact, if nothing had disturbed that region, it almost certainly wouldn't have failed. By every ordinary rule of planetary construction, another world should be orbiting the Sun there today. Instead, the process froze halfway through. Some objects managed to grow. Most never did. And whatever interrupted them left behind something extraordinary. Not the ruins of a planet, the unfinished foundations of one. For a long time, astronomers searched for an explanation inside the asteroid belt itself. Perhaps the rocks were too different. Perhaps collisions prevented larger worlds from forming. Perhaps the whole region was simply unusual. Each idea seemed reasonable. Each one eventually ran into the same problem. None of them could explain where almost all of the missing material had gone. Then another clue appeared. It wasn't hidden inside the rocks. It was hidden in the empty spaces between them. When astronomers mapped the asteroid belt in detail, they expected to see a crowded swarm stretching all the way around the Sun. Instead, they found lanes that looked almost deserted. Long, clean gaps cut straight through the belt. At first, they seemed almost accidental. Space is messy. Random clusters appear everywhere. Empty patches aren't unusual. But these gaps weren't random. Every one of them appeared in exactly the place where an asteroid would orbit the Sun a simple number of times for every orbit made by Jupiter. 3 trips for every 1 made by Jupiter. 5 for every 2. 7 for every 3. Again and again, the same pattern returned. It was as though something enormous had reached across hundreds of millions of kilometers and kept sweeping those lanes clean. An asteroid drifting into one of these regions didn't collide with a giant planet. Most never came anywhere near Jupiter. Instead, every few years, Jupiter's gravity tugged on it from almost exactly the same place in its orbit. 1 pull meant almost nothing. 1,000 pulls mattered. 1,000,000 changed everything. Little by little, the asteroid's path stretched farther from a perfect circle. Its orbit became longer, more tilted, more unstable. Eventually, many asteroids were thrown completely out of those regions. The empty lanes weren't scars left by an ancient explosion. They were still being carved today. For the first time, the asteroid belt stopped looking like an abandoned pile of rubble. It started behaving like a place under constant influence. And Jupiter was impossible to ignore. Not because it was close. It wasn't. On average, Jupiter circles the Sun hundreds of millions of kilometers beyond the asteroid belt. Yet its gravity is so overwhelming that it still shapes the motions of countless smaller worlds lying between it and Mars. That realization explained the gaps. But it created a much larger problem. The gaps account for only a small fraction of the asteroid belt. Most asteroids don't live inside them. Most orbit in regions where Jupiter's pull is much weaker. So why did almost all of the original building material disappear anyway? The numbers refused to match. Jupiter could explain the empty lanes. It could not explain why an entire planet never emerged. Something far more dramatic had happened before the solar system settled into the quiet arrangement we see today. For billions of years, Jupiter has looked like the giant that guards the edge of the inner solar system. Massive. Stable. almost permanent. It's easy to imagine that it has always been exactly where it is today. Almost every picture of the solar system shows it that way. But the young solar system was nothing like the calm place we know now. The planets were still forming. Gas still filled the space between them. Nothing had fully settled. And Jupiter itself was still moving. Not quickly enough for anyone to notice. But over hundreds of thousands of years, that was more than enough. As Jupiter grew, its gravity reached farther into the disk of rock and gas surrounding the young sun. The giant planet began exchanging momentum with that disk. Very slowly, its orbit started to shrink. Jupiter drifted inward. Not by a few thousand kilometers, by hundreds of millions. Straight toward the region where another rocky planet was beginning to grow. Imagine trying to build a city while someone keeps driving a bulldozer through the construction site. Walls go up. Then disappear. Foundations are laid. Then buried. Nothing stays in place long enough to become permanent. Something similar was unfolding between Mars and Jupiter. The rocks there hadn't stopped growing because gravity failed. Gravity was working perfectly. That was the problem. Every growing body kept feeling the pull of the largest planet in the solar system. Their orbits stretched. They began crossing one another's paths. Collisions changed. Instead of gentle impacts that allowed two bodies to merge into something larger, they began striking each other at several kilometers per second. Those weren't building collisions anymore. They were demolition. A crash that might once have created a larger world now shattered both objects into smaller pieces. The more chaotic the region became, the harder it was for anything to survive long enough to keep growing. Planet formation hadn't simply slowed. It had reversed. The construction site had become a wrecking yard. Yet even that wasn't the strangest part. Jupiter didn't stay there. After moving inward, another giant planet was changing the story as well. Saturn was growing. As the two giants began interacting, their gravity altered each other's paths. Instead of continuing toward the sun, Jupiter turned around. It started moving outward again. By the time the giant planets finally settled into orbits close to the ones we see today, the region between Mars and Jupiter had been crossed twice. Most of its original material had already been scattered away. Some fragments fell toward the sun. Some were flung into the outer solar system. Some escaped entirely. Only a tiny fraction remained behind. Not enough to finish the job that had already been interrupted. The asteroid belt wasn't left unfinished because nobody stopped building. The builders were forced off the site before the work was done. For a long time, that sounded like the end of the story. A giant planet wandered through the young solar system. Another planet never had the chance to form. Case closed. Except the rocks left behind refused to tell such a simple story. If every asteroid had grown in the same place, they should all look broadly alike. Not identical, but related, like pieces of the same unfinished building. Instead, they looked as though they had come from completely different worlds. Some are dark and rich in carbon. Others are bright, dry, and stony. Some contain far more metal than their neighbors. At first, those differences didn't seem unusual. The asteroid belt is a busy place. Different rocks can have different histories. But when scientists examined meteorites that had fallen to Earth, another pattern quietly emerged. The chemistry didn't just vary. It split. One family carried the chemical fingerprints of the inner solar system, where temperatures were high and rocky worlds were taking shape. Another carried signatures that belonged much farther from the Sun, beyond the orbit where Jupiter formed. These weren't cousins. They weren't even born in the same neighborhood. Yet somehow, today, they orbit side by side. That shouldn't happen. The young solar system wasn't constantly stirring itself like a bowl of soup. Material that formed close to the Sun generally stayed close. Material that formed far away usually remained far away. Something had mixed these two families together, and whatever had done it must have been powerful enough to move entire populations of asteroids across the solar system. Suddenly, the asteroid belt changed one last time. It wasn't just the place where a planet failed to grow. It had become a record of the chaos that reshaped the entire solar system. The dark, carbon-rich bodies weren't simply visitors. Many appear to have been carried inward from the cold outer regions as Jupiter and Saturn reshaped their own orbits. The rocky asteroids closer to the Sun survived the same upheaval from the opposite direction. When the giant planets finally settled down, both populations were trapped together inside the same narrow band of space. The asteroid belt became something no scientist had expected. Not a family. A collection of survivors. Each asteroid carries the memory of where it began. Together, they preserve the path the giant planets took billions of years ago. Nothing about the belt looks remarkable from a distance. Just a thin ring of drifting rocks between Mars and Jupiter. But hidden inside that quiet band is the evidence that the solar system we see today wasn't built peacefully. It was rebuilt while it was still being born. For billions of years, those rocks have continued circling the Sun. Colliding. Breaking apart. Slowly changing. But one thing has never changed. They have never started building a planet again. The reason is surprisingly simple. Planet formation depends on gentle collisions. Imagine two snowballs drifting toward each other. If they meet slowly enough, they stick. Do it again. Then again. Soon, a snowman begins to take shape. That is how rocky planets are born. One collision at a time. The asteroid belt works differently. Objects there don't usually meet gently. They meet at speeds of around 5 kilometers per second. Fast enough to cross an entire city in less than 2 seconds. At those speeds, rocks don't merge. They explode. Instead of creating something larger, each impact creates hundreds of smaller fragments. Every collision resets the process. Growth never catches up. Even the largest survivors carry the scars. One of them, Vesta, still bears an impact basin so enormous that it nearly tore the object apart. Pieces blasted from that collision eventually reached Earth as meteorites. Not because Vesta was becoming a planet, because it was still being broken apart. Even today, astronomers occasionally watch fresh collisions unfold. A faint cloud of dust suddenly appears where only a single asteroid had been seen before. Weeks later, the cloud stretches into a long trail as sunlight and gravity pull the fragments apart. Nothing new is being built. Another body has simply joined the debris. The asteroid belt isn't frozen in time. It's active, just not in the direction we usually imagine. Every year, every century, every million years, it moves a little farther away from becoming a planet. That is why the asteroid belt survives. Not because it escaped change, because change itself prevents anything larger from ever returning. The picture now looks completely different from the one people imagined 2 centuries ago. The asteroid belt isn't the wreckage of a world that exploded. It isn't a construction project waiting to be finished. It is a place where construction became impossible. Gravity built the planets closer to the Sun. The same gravity, redirected by Jupiter, prevented another one from ever joining them. The missing planet was never destroyed. It was interrupted. And the evidence has been orbiting between Mars and Jupiter ever since. The asteroid belt still circles the Sun exactly where it always has. Nothing about its appearance suggests that one of the solar system's oldest ideas quietly died there. From a distance, it remains what it has always seemed to be: a thin ring of drifting rock between Mars and Jupiter. Only after weighing it did that familiar picture begin to change. Only after tracing the chemistry locked inside meteorites. Only after mapping the empty lanes carved by Jupiter's gravity. Only after rebuilding the first few million years of the solar system. Piece by piece, the same conclusion kept returning. No planet exploded here. No shattered world filled this orbit with debris. What survives today is something far rarer. A permanent record of a planet that never had the chance to exist. The solar system did not simply leave this place unfinished. It prevented it from ever being finished at all.